Welcome to another video. My today's presentation is on differentiation. I'll tackle the basic principles of differentiation, identification of stationary points using both graphical methods and calculation from the equation of the curve. Please follow to the end to get the essence of differentiation in real life. The gradient function of the form y is equals to x to power n. Suppose we want to get the gradient of a curve y is equal to x squared at any point x, y. It will follow that for any point on the curve will be denoted by the coordinates x, x squared. Suppose we take a small change in x, say h, then the new point will be denoted by x plus h, then x plus h squared. We have the diagram. In this diagram, we have our curve y is equals to x squared, this curve. We have our point P, which takes the coordinates of x, x squared, and point Q, which takes the coordinates x plus h into bracket x plus h squared. On the horizontal axis, the x-axis, we have our x, and then we have the point x plus h squared. Because we have a small change in x, which is h, so from point x, we move to point x plus h. Therefore, the coordinates of Q will be, the x coordinate is x plus h, and the y coordinates, because the x squared, it will be x plus h squared. Suppose we take an equation of the curve as y is equal to x squared. At any general point xy, the coordinates will be x squared, x will be x, x squared. If we take a small change in x, say h, the new point will be denoted by x plus h, x plus h squared. From the diagram, we can see now our initial point P, we have x, x squared. We have introduced a small change in x, say, which is h. Therefore, we have moved from x to x plus h. The coordinates of point Q now will be the coordinate of x as x plus h, then the coordinate of y will be x plus h squared, because y is equal to x squared. From the diagram, we can see that moving from point P, x, x squared, where we have the coordinates as x, to x plus h, the change in x is x plus h minus x. And the change in y will be x plus h squared minus x squared. Gradient of PQ will be given by change in y, which is x plus h squared minus x squared, all over change in x, which is x plus h minus h. The gradient of PQ will be given by the change in y, which is x plus h squared minus x squared, all over change in x, which is x plus h minus x. X plus h squared will be given by x plus h multiplied by x plus h, which will be equals to, multiplying x by x, you get x squared, x times h you get plus xh, h times x plus hx, h times h plus h squared. This is x times h is the same as h times x, so we'll have x squared plus 2 of this, 2xh plus h squared minus x squared all over now the denominator, which is x plus h minus x. Simplifying, we'll have x squared minus x squared, that one will be 0. So we'll have 2xh plus h squared all over x minus x, which is 0. So we'll be left with h. Factoring out h because it is common here, we'll have h into bracket 2x plus h all over h. You can cancel off the h such that we are left with 2x plus h as our gradient of PQ. We shall use the arrow to denote approaches or tends to. We shall use the arrow to denote approaches or tends to. As Q approaches P, then H will approach 0. As Q, this point Q, approaches P, then our small change H will approach 0. Therefore, the limit 2x plus h as h approaches 0, it will be equals to 2x. Therefore, lim 2x plus h as h approaches 0 is equals to 2x. To conclude, the gradient of the curve y is equal to x squared at any general point xy is given by 2x, which means the gradient function of y is equal to x squared at any general point is given by 2x. Note that this 2x, which is the gradient function of the curve y is equal to x squared at any general point xy, can be used to get the gradient of any point on that curve. The expression 2x obtained is called the gradient function of the curve y is equals to x squared. The next thing to note is that the gradient function can be used to determine the gradient of the curve at any point. Number 3 to note is that in general, the gradient function of the curve y is equals to x power n, the gradient function, that is dy dx, is obtained by multiplying the coefficient of x by n. So n times, the coefficient of x here is 1. So it will be n times 1, which is n, multiplied by x, then you reduce the power of x by 1. In general, we'll get the power of x, our power of x, which is n, multiplied by coefficient of x, which is 1. So it will be n times 1, which is n. Then we reduce the power of x, which is n, by 1. We can also check here what happened. We had the power of x as 2, and our dy dx, we got it as 2x. So what happened? 2 times the coefficient of x is 1, you get 2. You reduce the power of x by 1, so 2 minus 1, which is 1. So you have x power 1, where n is a positive integer. Consider the curve y is equal to 4x cubed plus 3x squared minus 4x plus 2. You are asked to find the gradient function. The gradient function, which is our dy dx, will be given by, we consider the first term, 4x cubed. The power of x is 3, so you say 4 times 3 times x. X, you reduce the power of x by 1, so that will be 2, plus, here we have the coefficient of x is 3, so you say 2 times 3, x, you reduce the power of x by 1, so it should be 1, minus, the power of x here is 1, so 1 times 4, which is 4, then when we reduce the power by 1, it becomes x to the power 0, which is equals to 1. Therefore, this one becomes 12 x squared plus 3 times 2, 6x minus 4. That is our dy dx. Example 2, you are given the curve y is equal to ax cubed minus 3x squared minus 2x plus 1. Has a gradient of 7 when x is equals to 1. Find the value of a. Solution. Our dy dx will be given by, this is 3 times a, which is 3a, then we reduce the power of x, minus 2 times 3, which is 6, reduce the power of x, this is 1 minus 2, because this is 1 times 2, which is 2, then x power 0 is 1. We are told that the gradient is equal to 7 when x is 1. Therefore, the dy dx is equal to 7 when x is 1. So dy dx is equal to 7 when x is 1. So we substitute x as 1. Then opening the bracket, we have 7 is equals to, this is 3a minus 6 minus 2. Take the negatives to this side. So we'll have 6. So this will be 6 plus 7, then plus 2 is equal to 3a. This gives me 15 is equal to 2 to 3a. Therefore, my a is equals to 15 divided by 3, which is equals to 1. Example 3. A projectile is fired vertically upwards at any time t seconds. Its height in meters above the ground is given by height is equal to 30 t minus 5t squared. The first question you ask, how fast is it moving at Roman 1, t is equal to 1 second, Roman 2, t is equal to 2 seconds. And then number B, how far upwards does it travel? We asked how fast. The word fast here means the speed, which is actually the velocity. And when you are given the distance, the velocity is change in distance over change in time. Change in distance over change in time, which is equals to the power of t is 1, so that will be 30, minus the power of t is 2, so t times coefficient of t, which is 5, then we choose the power by 1, so you have 30 minus 10t. This is now the speed. We are asked the speed when t is equal to 1 second. So when t is 1 second, when t is equal to 1 second, to follow that we'll have 30 minus 10, we substitute t as 1. So this gives us 20 meters per second. When t is equal to 2, then we'll have 30 minus 10, substitute t as 2. So this becomes 10 meters per second. We know that when we want to get how far an object travels, but being asked how far upwards does it travel. In other words, we are being asked to get the maximum distance covered by this particle. At that maximum, then it comes down. There will be a stationary point there. At that point, the velocity will be 0 because the particle is not moving any further. Therefore, we want to get at that point where the velocity, which is distance over time, is equal to 0. So at that point, dh dt, which is our velocity, will be equal to 0 at that point, the farthest point. Therefore, it will be our velocity of action, which is 10 minus 30 minus 10t, must be equal to 0 at that point. Therefore, 30 will be equal to 10t, 3 will be equal to t. Because we are dividing by 10 on both sides. So that time will be after 3 seconds. Now, how far? We want to get the distance. Therefore, we have the t and we have our distance function here. So in that case, it will be, our height will be equal to 30, we substitute our t as 3, then we subtract 5, we substitute our t as 3 squared. So this will be 90 minus, this is 9 times 5, which is 45. Therefore, our height will be equal to 45 meters. In this part B, we ask how far. We know that when you fire something upward, it will reach to a point and then start coming down. So it will move up, then come down. At that maximum point, there is no speed. So the speed will be 0. So our gradient function of the velocity, that is distance over change in distance over change in time, will be equal to 0 at that point. Therefore, we equate our velocity function 30 minus 10t to 0 because at that point it is 0. So equating, we take negative 10 this side, 30. So we have 30 is equals to 10t. Dividing by 10, we have 3 is equal to t. We have time. At that maximum, our time is t. Our time t is 3 seconds. So we substitute that 3 seconds in our distance function to give us our height. So substituting t as 3, we'll have the height is equal to 30 into bracket 3 minus 5 into bracket 3 squared. Opening the bracket, we have 30 times 3 is 90. This is 9 times 5, 45. When you subtract together, the maximum height is 45 meters. We are now turning to a new subtopic, that is equations of a tangent and normal to a curve. When you have a curve, like the one that we have here, y is equal to x squared, I have point P, which is 1, 1, which is on the curve. The tangent to the curve at point P, which is 1, 1, is the line that I've drawn in red. Now, the normal to the curve is a line that is drawn which is perpendicular to the tangent at the point where the curve where the curve and the tangent meet at that point P11. This is the normal, this is the tangent. Tangent is any line that is touching a curve at any point, at any given point. In our case, our point is 1, 1. So we have the tangent, the one that is in length. The normal is the line that is perpendicular to the tangent at that point. We have one example here that we asked to find the equation of the tangent and normal to the curve. Y is equal to x squared plus 4x minus 3 at the point 1, 2. Solution. At the point 1, 2, we need to get the gradient of that curve at that point. dy dx will be given by 2x plus 4. This is the gradient of the curve at any particular point. But we're interested in this particular, we're interested in this point 1, 2. So we substitute our x to give us the gradient at that point. Our x is 2, so substituting so this will be 6. So the gradient at 1, 2 is equal to 6. That's the gradient of the curve at that point. We had the gradient of the curve at any point, which is 2x plus 4. But our question is based on at this particular point 1, 2. So our x is 1. So we substitute x and we get that the gradient is 6. At this particular point, we have got our gradient as 6. So the gradient of the tangent at that particular point must be equal to the gradient of the curve. Therefore, our gradient of the tangent will be we consider a point xy on the tangent. We consider a point xy on the tangent. Therefore, the gradient of the tangent will be changed in y, that is y minus 2 all over x minus 1, which must be equal to 6. We are equating the gradient of the tangent to the gradient of the curve at that point because the gradient of the tangent is uniform, because it's a straight line. So we'll have 1 point, 1, 2, and then we are considering another point x1, so that y minus 2 all over x minus 1 is equal to 6. So we multiply by x minus 1 on both sides, so we'll have y minus 2 is equal to 6 into x minus 1. Y minus 2 is equal to 6x minus 6. Take negative to the other side, so y is equal to 6x minus 4 plus 2. Y is equal to 6x minus 4. That is the equation of the tangent. Considering the general equation of a line, y is equal to mx plus c. Our m denotes the gradient. Denotes the gradient. For perpendicular lines, m1, m times m1 is equal to -1. In this case, we have the tangent and the normal, which are perpendicular, and therefore the product of the gradient must be equal to -1. We have the gradient of the tangent as 6. Therefore, 6 times m1 must be equal to -1. So the gradient of the normal is equal to -1 all over 6. Consider a point x, y on the normal. And 1, 2. x1 on the normal and 1, 2. It will follow now that change in y over change in x is equal to -1 all over 6. We cross multiply. So we'll have 6 y minus 2 is equal to -1 x minus 1. Opening the bracket, we'll have 6y minus 12 is equal to -x plus 1. You take -12 to the other side, so we'll be left with 6y is equals to -x plus 13. The moment it crosses the negative, the equal sign becomes positive. So our y will be equals to -1 over 6x plus 13 all over 6. That is the equation of the normal. We now move to stationary points. Consider the curve y is equals to x squared plus 2x plus 3. Our gradient function, that is dy dx, will be given by, we multiply the coefficient of x by 2 to get 2, then we reduce the power of x by 1 to get 1, so we have 2x. Then in the next one we multiply the coefficient of x, which is 2, by 1, which is 2, then we reduce the power of x by 1 to give us 0, so we'll be left with 2. Therefore, our gradient function at that point is 2x plus 2. We move to the table. This table, we are taking the values of x from -2 all the way to +3. How did we get now the value of y? We substitute the value of x into our curve. For example, to get 6, we substitute here, our x is -3, so we'll have -3 squared plus 2 into -3 plus 3. So this gives us 9. Negative times positive times negative, we have -6 plus 3. So we'll have 9 plus 3, which is 12. 12 minus 6, we get 6. To get y as 3, we are substituting -2 into our curve. So we'll have -2 squared plus 2 into -2 plus 3. So this will be -2 squared is 4 minus this -2, the positive 2 times -2, that is -4 plus 3. So 4 plus 3 is 7 minus 4, we get 3. And to get the other values, we do the same. We substitute the value of x into our y. Now to get dy dx, which is our gradient function, as negative form, we are substituting negative 3, that is our x, into our gradient function, so we'll have 2 into negative 3 plus 2. So this gives us 2 times negative 3, we get negative 6 plus 2, which is equal to negative 4. That's how we get the dy dx when x is equals to negative 3 as negative 4. So when x is equals to negative 2, we get our dy dx as negative 2. That is, substituting our x here as negative 2, in our gradient function, we'll have 2 into negative 2 plus 2. So this is negative 4 plus 2, which is equals to negative 2. That's how we get the gradient function. The gradient function, that is dy dx, when x is equals to negative 2, our dy dx is also negative 2. When our x is negative 1, we get our dy dx as 0. Basically, we substitute here. Negative 1, we add to 2, so this will be negative 2 plus 2, which is equals to 0. That's how we arrive at dy dx is equals to 0 when our x is equals to negative 1. And then it continues until up to where we have 8. That's how we get our dy dx. Now we need now to present this table as a graph. On our graph, we can see that when the value of x is negative 1, dy dx is equal to 0. When the value of x is negative 1, dy dx is equal to 0. The gradient of the curve at that point, negative 1, 2, is equals to 0. To the left of that point, the value of dy dx is negative. Negative 2, negative 4. To the right of that point, that is negative 1, 2, any value is positive. The any value of dy dx is positive. You can see when x is 0, our dy dx is 2. When x is 1, our dy dx is 4. So it is positive. So in that case, we have 3 points to note. One is that when we have the point negative 1, 2, our dy dx is equal to 0. Any other value of x to the left will give us our dy dx as negative. Any other value to the right of x is equal to negative 1 will give us our value of dy dx as positive. Therefore, our point negative 1, 2 is a minimum point. We start from the far left, we have negative, then 0, then to the other side we have positive. So our dy dx at the point negative 1, 2 is giving us a value of 0, and that point is a minimum to this curve. This is a simplification of this graph. We are moving from the left, we have dy dx is negative, we come to where dy dx is 0, then to the right, dy dx is positive. So this gives us a minimum point. Consider the curve y is equal to x cubed minus 3x plus 2. The gradient function dy dx will be 3x squared minus 3. Taking the values of x from negative 2 to positive 3, we'll have the values of y and the values of dy dx at that point x. When you have x as negative 2, to get the value of y as 0, we are substituting negative 2 in our equation of a curve. So we'll have, when x is negative 2, cubed minus 3 into negative 2 plus 2. So we'll have negative 2 cubed is negative 8. Negative times negative is positive. plus 2. So we get negative 8 plus 8, which is equal to 0. That's how we are getting the value of y. Now to get the next value of y as 4, we substitute negative 2. We substitute negative 1. So it will be negative 1 cubed minus 3 into negative 1 plus 2. So this gives us negative 1 plus 3 plus 2, which is equals to negative 1 plus 5, which is equals to 4. That's how we are getting the values of y. Now to get the dy dx, we substitute the value of x into our gradient function. So for example, when x is negative 2, to get 9 as dy dx, we are substituting here. So we'll have 3, our x is negative 2 squared, then minus 3. This is 3, negative 2 squared is 4, minus 3. So this is 3 times 4, which is 12, minus 3, which is equals to 9. That's how we are getting our gradient function, dy dx, at the point x is equal to negative 2 is 9. At the point x is equal to negative 1, how do we get 0? We substitute x as negative 1 minus 3. So negative 1 squared is 1, 1 times 3 is 3, 3 minus 3 is equal to 0. That's how we are getting these values in the table. Presenting the table into this graph, xy graph, in the Cartesian plane xy graph, we'll have now, when our x is negative 2, we have our y as 0. When x is 1, we'll have our y as 4. When x is 0, we'll have our y as 2. When x is 1, our y is 0. And when x is 2, our y is 4. When x is 3, our y is 20. From our graph, y is equals to x cubed minus 3x plus 2, we'll have, when x is negative 2, our y is 0. And our gradient is positive 9. When x is negative 1, our y is 4. And our dy dx is equal to 0. So that is a stationary point, because the gradient is a horizontal line and the gradient is equal to 0. When x is 0, we have our y as 2, positive 2, and our dy dx as negative 3. Now the curve is going down. At x is equals to 1, y is 0. We have another horizontal line. Our dy dx is equal to 0. When x is 2, our y is 4. And our dy dx is positive 9. So the gradient is positive. When x is 3, our y is 20. At that point, our dy dx is positive 24. So we have two stationary points here. We have one stationary point when x is negative 1, our y is 4. That point, negative 1, 4, is a stationary point because our dy dx is 0. This stationary point is a maximum point. We are moving from positive, the gradient changes from positive through 0 to negative. So that one is a maximum point. Then we have another point here, dy dx, whereby our gradient changes from negative through 0 to positive. So that one is a minimum point. Just like the graph is indicating, we are moving up, then down, so this is maximum. When we are down here, then we move up again, so this one is a minimum point. So this particular graph gives us two stationary points. One being maximum, the other one minimum. For any point xy, that the gradient is changing from positive through 0 to negative, that point is a maximum point. The minimum point and the maximum point are referred to as the stationary points. The value of y at the minimum or maximum point is not necessarily the greatest or least value of the curve. The curve may have other greater or smaller values at other points. Consider the curve y is equal to x cubed minus 3x plus 2. From our definition, we know that stationary points occur when dy dx is equal to 0. So what is our dy dx given our curve is x cubed minus 3x plus 2. dy dx is equals to, we multiply the coefficient of x by the power of x, that is x times 3, then we reduce the power of x by 2, by 1. So we'll have 3x squared minus the power of x is 1, multiplied by the coefficient of x, which is 3, comes 1. We reduce the power of x by 1, so it will be 1 minus 1, which is 0. So our x disappears. So we'll have 3x squared minus 3. Stationary points occur only when dy dx is equal to 0. Now we have our dy dx as this. So we equate our dy dx to 0 to get the stationary point. So we equate this one to 0. So we'll have 3x squared minus 3 is equal to 0. Taking negative to the other side, we'll have 3x squared is equal to 3. So we can divide by 3 on both sides. Divide by 3. So we'll have x squared is equals to 1. X squared is equals to 1, meaning that we have two possibilities. X can be equals to 1 or negative 1. Because negative 1 squared is equals to 1, 1 squared is equals to 1. Therefore, the values of x are negative 1 or positive 1. So what will be the value of y when x is equals to 1? So that we get the stationary point. When x is equal to 1, what will be the value of 1? Our y will be equals to, substitute 1 there, so it will be 1 cubed minus 3 into 1 plus 2. So this will be 1 minus 3 plus 2. So this one will be equals to 0. Therefore, our point, the first stationary point, is 1, 0. Then you get the second stationary point when x is equals to negative 1. So you'll have, when x is equal to negative 1, what will be the value of y? Y will be equals to negative 1 cubed minus 3 into negative 1 plus 2. So this will be negative 1 plus 3 plus 2. So 5 minus negative 1, 5 minus 1, you get 4. So we have our stationary point as negative 1, 4. So we have two stationary points there. One is 1, 0, the other one is negative 1, 4. We need now to identify the stationary point. Identification means you say whether they are positive, whether they are maximum or minimum points. So let's start with the first one. The point 1, 0. Point 1, 0. For the first point, we have point 1, 0. Our value of x is 1. So we need to consider a value of x that is before, is before 1 and another value of x that is after 1. So let's consider when we have x is equals to 1. Let us consider the value of x to the left. Say x is equal to 0. When x is equal to 0, what is happening to our dy dx when x is equal to 0. When x is equal to 0, our dy dx will be given by, will be equal to 0 squared, so our dy dx will be equal to negative 3. Then we consider another value of x after 1. Let's say 2. Let's say when x is equal to 2, what will be our dy dx? Our dy dx will be, when x is equal to 2, we will have 3 into 2 squared minus 3. So this will be equal to 12 minus 3, which is equal to 9. Now we have, when x is 2, our value of dy dx is 9, which is positive. When dy dx is negative 3, our value of x is 0. So this is negative. So we started before, then after. So before, our dy dx is negative. That is before. So negative. Then we have our 0. Then after, when x is equal to 2, we have a positive value. Therefore, our point 1, 0 is minimum. Is a minimum point. Our point 1, 0 is a minimum point. Considering the other stationary point where x is equal to negative 1, x is equal to negative 1, we will consider another value of x to the left. Let's say negative 2. Let's say when x is equal to negative 2, what will be the value of, what will be the dy dx will be equal to what? We substitute negative 2, so we'll have 3 into negative 2 squared minus 3. So this will be negative 2 squared is 4, and 3 is 12. 12 minus 3 is equal to 9. So this is, our dy dx is positive. Let's consider another point after negative 1. Let's say 0. When x is equal to 0, what is the value of y dy dx? Our dy dx will be, substituting 0 here will be 0, so it will be negative 3. So this is negative gradient. Therefore, we are moving from positive to 0, then negative. We can see that when x is equal to negative 1, we have a stationary point. To the left, when x is negative 2, we have a positive value, a positive gradient. So, positive gradient. Then we have 0. When x is 0, we have a negative gradient. Therefore, we have a maximum point. Therefore, point negative 1. Therefore, point negative 1, 4 is a maximum point. Let's now move to application to velocity and acceleration. How we apply now dy dx to get velocity and to get acceleration. From our definition, we know that velocity is the rate of change of distance with respect to time. Change of distance with respect to time. That's what we refer to as the s dt, where s stands for distance and t stands for time. Velocity is the rate of change in distance with respect to time. So this is our velocity, and it is usually written in meters per second. Acceleration is the rate of change in velocity with respect to time. Change in velocity with respect to time. Acceleration. So it will be written as dv dt. Change in velocity in respect to time, and is always written as in meters per second squared. Acceleration is written as meters per second squared, denoted by letter A, velocity denoted by letter V. Example, the displacement x meters of a particle after t seconds is given by x is equal to t cubed minus 2t squared plus 6, where t is greater than 0. The first question is, you have to calculate the velocity of the particle in meters per second when t is equal to 2 seconds. Solution. Velocity is given by change in x over time. Our x is given, so our dx dt will be equals to, will be given by multiply the coefficient of t by 3, then reduce the power by 1. So that will be t squared minus multiplying 2 by the coefficients of t, which is 4, we reduce the power by 1, so it will be 4t. That is our dx dt. We are asked to calculate when t is equals to 2 seconds. Our dx dt, which is our velocity, is given by 3t squared minus 4t. Now we have to get this velocity when t is equal to 2 seconds. So we substitute t as 2. So this gives us 2 squared is 4 times 3 is 12 minus 8, which is equal to 4 meters per second. In part B, we asked that when the velocity of the particle is 0, calculate displacement and then acceleration. So the velocity will be equals to 0 when dx dt is equals to 0. Velocity of a particle is 0 when dx dt is equals to 0. And our dx dt is 3t squared minus 4t. So we put this one to 0 to get our t. So we can have 3t squared is equals to 4t. Taking this to the other side, divide by t on both sides. Divide by t, divide by t. So you'll have 3t is equals to 4. So our t is equals to 4 all over 3 seconds. So we want to find the displacement when t is equals to 4 over 3 seconds. And our displacement function is x is equals to t cubed minus 2t squared plus 6t. So we substitute our t in this displacement function. So we'll have x is equals to 4 all over 3 cubed minus 2 into 4 over 3 squared plus 6. Opening the bracket, we'll have 4 cubed as 64, 3 cubed is 27, so we'll have 64 over 27. Opening the bracket, you'll have 4 squared is 16, 3 squared is 9, so 16 over 9 times 2, we get 32 over 9 plus 6 over 1. The LCM of 1, 9, and 27 is 27. So 27 divided by 27, we have 1 multiplied by 64, we get 64. 27 divided by 9, we get 3. 3 times 32, we get 96. 27 divided by 1, you get 27. Multiplied by 6, you get 162. When you add 64 and 162, then you subtract 96, we get 130 over 27. 130 divided by 27 gives us 4.815 meters. That is the displacement when the velocity is 0. Solution to B2, we have to calculate the acceleration when the velocity is 0. Our velocity is 3t squared minus 4t. Therefore, what is our acceleration? Acceleration is equals to dv dt. And we have our v as 3t squared minus 4t. So our dv dt will be equals to multiplying the coefficient of t by power of t. So you get 6t, because we are reducing the power by 1. 2 minus 1, we have 1, so it will be 6t. Then we move to the next. Our power of t is 1. Multiplied by the coefficients of t, which is 4. 1 minus 1 is 0, so t disappears. So we have acceleration as 6t minus 4. We want to get this acceleration when the velocity is 0. And when the velocity is 0, dx dt is equal to 0. We have our t as 4 over 3 seconds. So we substitute our t as 4 over 3. So it will be 6 into 4 over 3 minus 4. So we can cancel here by 3, 1, by 3, 2. So 2 times 4 is 8. We subtract 4. So this gives us 4 meters per second squared. We are now turning to further application, and we have given an example here. A farmer would wish to use 28 meters length of fencing wire to make a rectangular enclosure for his goods. What is the maximum area that the enclosure can have? Solution. Let the perimeter of the enclosure have length x and y, such that now the perimeter of the enclosure will be 2x plus y. That is the perimeter. Our P is the length, is the length of the wire that we like to use. So 28 will be equals to 2 into x plus y. Therefore 14 is equals to x plus y. X will be equal to 14 minus y. Therefore area will be given by y multiplied by 14 minus y. We substitute x. So now the area will be y into 14 minus y. Because our x is 14 minus y, and the area is length times breadth, which will be y times x. So we have y, and our x is 14 minus y. Therefore, the area is equals to y into 14 minus y. opening the bracket, we'll have 14y minus y squared. So our area A is equal to 14y minus y squared. The area will be maximum when dA dy is equal to 0. So our dA dy will be equals to and multiply these ones, we'll have 14 minus 2y. And it is maximum when dA dy is equal to 0. So we equate 14 minus 2y is equal to 0. 14 is equal to 2y. So 7 is equal to y. So when y is equal to 7, what is x? When y is equal to 7, x will be 7. When y is equal to 7, x will also be equal to 7. Hence the maximum area, will be given by 7 times 7, which is equal to 49 meters squared.